Hi, good morning. In case you were wondering if Michael and I were brilliant, the answer is yes, because here's what I did. I convinced you all to come to my talk here by scheduling Michael's talk next and Einar and Jorg's talk after that. So I appreciate you sitting in here and not just sneaking in at the second part of the talk. Today I'm going to talk to you guys about some experiences I've been having recently with assembling large bits of software and the interesting things that happen when things get large and complicated. So to spoil the punchline, here it is. Dependency injection is the idea that for a unit of software, it doesn't specifically depend on things. It depends on, say, an interface. And at some point later, you assemble the application by providing it the inputs it needs. And this improves testability because each part can be hooked up to a harness and you can test it independently. And without modularity, otherwise all the dependencies are directly in each one of the components, and that's no good. So we have an ability to manage this, but over time the complexity of the dependency injection system gets really, really tough. It's very complicated. So the question becomes, given that we're architects and we could have solved that problem if we were doing, say, a waterfall process where there was a design phase and you were going to come up with the modularity of the system up front, that could have been solved. We have a way of thinking about it and we could have thought about the problem. But if we were doing an iterative development cycle where we're going to build a little bit and deliver it and build a little bit and deliver it, the complexity sort of creeps up on us. And so the question becomes, how do we, at what point do we get in there and say we're going to architecturally intervene or apply the knowledge that we've got about architecture to do something? And so I suggest a couple partial solutions for this, which are to overcome some cultural obstacles to doing architecture in the middle of those iterations and some process obstacles. Okay, so that's the cat out of the bag. So if you're in the wrong talk, you can leave now. So for those of you that aren't intimately involved with doing dependency injection, here's a little tour of how this might go. Let's imagine you are making a coffee maker class. And so what you do is you've got your, it has two constituent parts, a pump and a heater. And so you create those things and assign them to instance variables. And then you've got a main method of brewing where you turn the heater on, you pump some stuff, you wait a little bit, you enjoy your coffee, okay? That sounds pretty good. And so we say, I'd like to write a unit test for this. So what does that look like? We've got the coffee maker test, and we do the setup, and we create our fake pump and our fake heater, and we create our coffee maker, and we go, oops, that's no good, because actually the coffee maker already specified which pump it was using and which heater it was using, so that's no good. So let's go fix that. Let's go back to the coffee maker. Okay, so this time, you'll notice that there's a pump and a heater field in that class, but we don't say which one we're going to use, and instead we pass them in the constructor. Okay, this is standard practice for allowing you to create coffee makers and not have them specify their dependencies. Okay, that looks great. Let's go back to the test again. Okay, so how does the test look now? This is much better. Okay, so what we do here, and you can see the parts in bold that are different, is that we create a new coffee maker and we pass in the fake pump and the fake heater, and we're able to run the test. Okay, so we have succeeded. We can now do unit testing, and this is a good thing, right? And we should stop now and go have cake and have a party and so forth, except that we've actually deferred the problem to somewhere else, because before we knew, as the coffee maker, which kind of pump and which kind of heater works in production. And we now have a test case that says, in the test environment, use the fake pump and the fake heater, but that leaves open the question, who knew that you were supposed to use the real pump, or which real pump and which real heater are you supposed to use in the production code? Okay, so let's go back to this original one. And so the standard solution, which I'm not going to completely describe, but just give you an idea, is that at least in Java, there's a standard in the Java community where you say @inject at the top of the coffee maker. And basically that says someone in the environment is going to configure me and pass the parameters into me that I need. Okay? So it defers the problem to somewhere else. We're going to have to define what that heater and pump should be. Okay. So that sounds pretty good. We've solved the production problem. We had already solved the testing problem. So let's go back to the test case. Okay. So we realized that actually the dependencies that we inject, the pump and the heater, themselves may require dependencies. And you're like, oh no, the dependency graph it's not just a list of dependencies, it's actually a graph. So for each one of these things, they require things which may in turn require things. It's getting more complicated, right? So we look at this and we say, this is no good. We can't be, in my test case, directly creating the dependencies and stick them in. We actually have to use that same injection mechanism inside my test cases. Okay, so we're going to do the obvious thing, and we're going to create this injector, and I just called it magic there, you can see. But pretend that there's an injector that, that holds that stuff, and what we're going to do is we're going to add my fake pump, and I'm going to add my fake heater, and all the rest of the dependencies that I need, and hand them to the injector. So then when I ask for the coffee maker, I ask the injector, please create me a coffee maker, and it's going to inject all the dependencies and all their dependencies and so on until it has everything necessary, and then we've got a coffee maker. Okay, so you can see how the complexity is marching up here as we go, right? So this is how you might behave on a project. You're like, each one of these problems is solvable. You've got like your judo move that gets you to the next phase, and we're going along, okay? So let's imagine that this long list in your otherwise simple test case starts to be a burden because as your system grows, the number of things you have to specify that are unrelated to the test case but just sort of harness to set things up grows bigger and bigger. So what you do is you create a method that groups all that standard stuff together. So it's like my test setup, and all of us as engineers on the project, we keep contributing those bindings, those here's another object that's a test version of something, and we keep sticking them inside there. Okay, so this is pretty good because we're still at the point now where we can do a test configuration and a production configuration, and those work, and we've got shared test setup that we can all contribute to. So the problem, though, is that with testing, you actually want to be, you want to have confidence that the test does what you expect it to do, right? So as soon as you're deferring to some magic test setup, you're never quite sure what the test setup was all about. Like, did it really hook up the environment that I was expecting it to do? So you go take a look at it and you find out it's this giant pile of bindings that everyone's just been dumping things into, and no one's really sure what's going on inside there. And when you get a big enough application, that test setup becomes like a big pile of complexity that you have to manage in its own right. So we've sort of been shuffling around the complexity from place to place over time, but it ends up in this big pile, and that's not so great. Okay, so I'm not going to give you a full answer to the story here, but I'm going to talk to you about the situation we find ourselves in. When we make it easy to unit test things, we can take any individual piece of our software and we can test it well, okay? But it's sort of like saying, here's all the pieces for the system, but I've taken away all the relationships between them, okay? And if you were a particularly good automotive engineer, you could probably put that car back together. But for most people, it would be a challenge. And actually, I would argue that there's a lot fewer pieces in that car than there are in like almost all the software that you guys are building today. Okay, so the alternative to just saying, here's a bunch of pieces, is here's the entire assembly instructions. Okay, here's how you put everything together. Well, again, if it's nice and small, those assembly instructions are comprehensible, right? You can get control over that. But when it gets big and large, and again, that's not even that many pieces. Imagine if you were to say, for my entire application, here's how everything gets wired up. That's complicated in its own right. So we're software architects. We already know the answer to this. The answer is to divide up the big thing into a bunch of smaller things, modules. Okay, so we chop it up into modules, and so you might say, this is an example of a computer, but there's a disk drive, and we understand the disk drive itself has more pieces, but we need to chop it up hierarchically. Okay, so where are we? Dependency injection is about saying that there's a big graph of dependencies of objects in your system, and if you're on a large team that's building software every day, those dependencies, believe it or not, are changing every single day. Okay, so keeping track of that is tricky. Package modularity is the idea that you can group a bunch of source code and call that a module. But what we find with dependency injection is people tend to inject individual classes rather than modules, okay? And you could make the shift at some point, but that's kind of tricky on a project, right? Because someone's already been well, the whole team has already been injecting classes the whole time, and you have to say, stop injecting classes, inject these big chunks. Instead of depending on the, for example, HTTP parameters that came in with the HTTP request, you might say, give me the request context, and like it's a whole pile of stuff that to get the granularity down to size. So testing is very fussy. Like we showed that you have a bunch of these dependencies, you may have to mock out certain things, and as we all know, if we're doing testing very well, the total sum of testing code can be greater than the amount of production code that we've got, okay? That's not at all uncommon. So what's the situation we're in? In the yellow box down at the bottom, we have lots of fine-grained dependencies that are changing daily. We have a forest through the trees problem. And the forest through the trees problem that we've got at hand is, how do I know I've got a legal configuration of the software, right? I have set up a test, and the test appears to run, but do I really have confidence that I've set it up in such a way that I'm testing the thing that I thought I was testing when the answer comes back positively? So basically, I would suggest that what we've got here is a trouble that it's hard to get intellectual control over this very complicated system. So what do I mean by intellectual control? Here's an example of something I would consider like that I have intellectual control over. Imagine you've got a photocopier, and you can have a couple different variants of the photocopier. It can have, say, a manual feed or an automatic feed as an input. It can have different kinds of engines for how fast it's going to make photocopies, and it may have different kinds of outputs. One's a standard tray, another one's a tray that'll staple the output, okay? So when I describe this thing to you, implicitly in the way that I described that, I was describing, here's a specific configuration, like the one at the top here, manual feed, 30 copies per minute, and stapling. That's one configuration. So that might be analogous to a test configuration that I was going to set up a test, or it could be equivalent to a production configuration that I'm going to run my system in. But at the bottom here, you've got this idea of all legal configurations, right? So if you think about your software system, it's probably kind of tricky to say, for all the different classes that I could have in the system, what are the legal combinations of which ones are allowed to be injected? Would I be in trouble if I didn't inject the HTTP parameters and instead injected some other kind of request parameters? Or does somebody depend on something implicitly that specific one works, but another one does not? So compare this with the idea of the screws and bolts, right? That if you looked at the car and you look at all the screws and bolts, I don't think you've got very good intellectual control. So what we're looking for, I would argue, for intellectual control is some understanding of a specific configuration and in a zoomed out aggregate sense, what are the all kinds of legal configurations? That's what I'm looking for, okay? So I think that that's really what all architects are looking for. So if you were reading this fine book by our moderator, Mr. Kaseman, then we would find that architects are concerned by of all kinds of things about modules, which are the static structure of your program. So how is the system decomposed into modules? What are the dependencies between the modules? What are the legal arrangements of the modules? And how big, how granular are those modules? And of course, is the system testable? And can I maintain the system testing infrastructure, right? Do I have an understanding of what's going on there? So these are standard things that we as architects are like saying, no big deal, we understand that. So I'm going to argue that in most of the systems I've seen, there's a missing concept of a system configuration. Okay, and I'm not claiming to have invented this or anything. I'm just saying that on most projects I see, we don't end up thinking about this explicitly. And in order to say that you've got a configuration, you've got to be able to say, group the code into modules and then describe the legal arrangements of modules, much like I did with that simple photocopier example a minute ago. And the reason I can get intellectual control is that I've got abstraction in at least two dimensions here. First is that the zooming out, it allows me to not think about little nuts and bolts and HTTP parameters, but instead I can think about large chunks and which chunks are variable, which chunks are required, and so forth. And also that the type versus instance distinction is important. I can say this is a particular configuration versus this is a description of all legal configurations. Okay? So I bet this rings true with you guys when you think about the common configuration instances that you have in your system. You've got the configuration you run on your machine. You've got unit or integration tests that are different configurations that you're going to run. And then certainly you've got a production configuration that you're expecting to run. And in fact, there might be many more, right? However, what I don't generally see is the configuration types. That is, the description of like, how is this system allowed to vary? What are the variability points? Which modules are required? Which ones can be repeated? And so forth. So let me give you a hypothetical timeline of how a project might evolve using modern iterative software development. That we start with a simple system where we've got simple dependency injection at the class level, okay? And we make a little system and we get it working, and the team grows and the system gets bigger, and we refactor the setup code into a shared method like we saw in the introductory example. And then that shared test setup becomes complicated in its own right, like I said, and it gets big, and it's a dumping ground, and everyone's putting bindings in there every day. And the rules for making a legal system, it's hard for any one person to keep it in their head because there's so much work going on in different places. And the ideas of what's legal are shared across a lot of different developers. They're in different config files. It just becomes really difficult to get that intellectual control that we're going for. Until finally, we end up with a situation where the test setup becomes a write-only dumping ground where people can put stuff in, but don't you ever take anything out because you have no idea, what ripple effects that's going to have, okay? So the essential question that I want to ask is, when would you add architecture to this timeline? And I know that's not a well-formed question, but you understand what I'm trying to say. The point is, you've got these ideas about architecture in your head, and you sort of have an idea if you were doing a waterfall process, there would be a point at which you decided on the modularity of the system. But given the way that this frog gets boiled, there's no real clear point for me anyway, where I jump in here and say, this is the exact point at which I would say, stop, it's time to organize my classes into modules so that I can prevent this problem that happens later on. And if you know the answer to this, let's chat afterwards because I'd love to know. But I think that this is actually pretty old news. Mary Shaw, our keynote from this morning, introduced me to this paper long ago, and it's the Programming in the Large paper by DeReamer and Cron, and it says exactly what I'm saying right here. And except the problem is that these guys wrote this in 1975, and they said, look, the configuration of the system's hard to find by looking at the code. We're so busy with trying to get this thing to work, and the information that you need is smeared out across the system. So this is trouble that there's a fair number of people in this room that are under 40. So this paper was written before you were born, and we still haven't managed to crack this nut, okay? So here's the situation I find myself in. You are the architect, steer the project, good luck, okay? And so we're trying to pull in all the best technologies we can. We're trying to do iterative development. We're feature focused, thank you. And how do we make that happen? So let me show you a parallel timeline that generalizes the one I just showed you specifically about testing and injection. Project starts up, it ramps up, it has continued growth, things are going great. Velocity starts slowing down because complexity is weighing us down. The developers propose refactoring things, but actually those refactorings get so expensive in their own right, they don't get done. Until eventually management says, look, it would be easier for me to rewrite this system than it would be for me to have you do these refactorings, okay? So this is the situation that I'm concerned about. It's not really clear across my cartoon of a timeline here when any particular concern became architecturally relevant. So even if we've got this great grab bag of technologies and comprehensions of abstractions over here as architects, it's not really clear how and when in an iterative development cycle when I can go in here and say, right now is the time for me to do architecture stuff. So I would say that practicing architecture is fairly difficult today. That the way that we used to think about doing things where we sat in a corner office and we told the large team of developers how to do stuff, we thought in advance in detail about how things are going to work, we wrote design documents and so forth, that didn't always have a great track record. So the modern software development tends to be iterative and feature-driven, and that presents challenges for me. Even though I have the architecture theory well sorted out, I think, in my head, I see two obstacles. The first one is cultural, and that it used to be that teams would think that they should be doing some design and they should have design documents and so forth. Even if they didn't have great ones, if you suggested they would do that, they would go along with it, okay? And it's harder to do that now because of the you ain't gonna need it kind of attitude. And they may be right. So the second one is process obstacles, that since there's no specific time when I'm doing macroscopic analysis or design work, instead I'm just sort of working away every day on immediate tasks, it's not really clear when I get in there and do this architecture. So I'm not completely pessimistic, and I'm so glad that certain people are in this room, that there's a culture of architecture that I think we can get into practice, and we need to understand what that means. The work I see being done by Simon Brown is a great example of this. He's trying to get architecture off the whiteboard and into the code. And so go see his talks that he's doing. The second is the microservices movement, where they're in the Agile community, they're focusing on architecture of a certain style, And I think that's an opportunity for us to bring in a lot of other architecture ideas into the Agile community and get them thinking about the same abstractions as we are. And then maybe somebody figures out how we do this Agile and architecture together at the same time. And second is that the process-wise, with short iterations, it's difficult to figure out how to do the traditional activities that we talk about that require sitting down, thinking about abstractions, writing them down, and then having this delayed gratification later on. Michael Keeling seems to be doing great work on this stuff, and he's preparing a book on this topic. And I'm going to out him right here in public, and you see, because not everyone knows he's working on a book, so now everyone's going to ask him about the book. And so he's got a grab bag of these great activities for getting developers together in the scope of a short iteration and doing architecture activities. I think that is a really promising thing. Also, if you guys think back to 10 years ago and you think about the tooling that we had around us, like we didn't have the continuous integration tools, we didn't have frameworks for doing automatic deployments, there's all kinds of tooling that has just risen up to support the style of iterative development that we do today. I think that same opportunity, there's an opportunity in that same space for architecture kind of tooling that we don't quite know the shape of, but that if you guys are all thinking about it, maybe we can figure out if there's similar sort of things to make the architecture visible. Simon has a tool called Structurizer that makes the architecture visible in the code as well. So I think those things are great opportunities. Here's the moral of the story, that dependency injection for me was just a way of telling this story about we have this monster of complexity that we have to attack. It creeps up on us slowly. As we do iterative development, feature-driven development, it's not clear when we can interject the sort of techniques that we used to apply in a waterfall-style process. So we got to figure out how we can get around that. So let's figure out how we can do architecture in that style of development, because I think that's a great way to build stuff, and the future is bright if we can figure out how to get it all work together. All right, thank you very much.